So now this question is more so a conceptual question, okay? Because it doesn't really have any problem with it. It just says calculate the energy of a photon of an electromagnetic radiation at each of the wavelengths indicated in problem 39. When I click on it, unfortunately, and I try to open it, I do get that. So unfortunately we don't have the whole thing. So here's what I'm going to do to explain how to usually do these. So when you want to calculate the energy of the photon, it's actually what we did in the previous question. So just remember these formulas, that energy is equal to Planck's constant times frequency, okay? And in fact, I keep saying Planck's constant, but I don't want you to pull up the wrong one. Planck's constant is indeed the one we're using. Phew, good. That is Planck's constant. Okay, and now it's asking us in terms of like more conceptually, this is what you're going to be using to calculate the energy of a photon, because they give you the wavelengths, and when you break down the frequency, because frequency is equal to the speed of light over wavelength. So as long as you're getting the wavelength, okay, so I'm going to actually circle this in blue. As long as you're getting the wavelength, you can solve for frequency. And as long as you can solve for frequency, you can solve for energy. The only thing you have to keep track of is your units. Make sure that your wavelength is going to be translated to meters, because that's what works with Planck's constant. Don't use the nanometer form. Just make sure you adjust accordingly by putting like 10 to the negative 7 or 10 to the negative 9. Point being is you want to keep track of that. But really, this is truly all you need. Just make sure that you can solve for frequency using this, okay? And then after, you can solve for energy. Or in fact, what I like to do, you can kind of just put the two equations together, and this is what you're working with. So you can always get the energy right away. Just plug it in, speed of light, Planck's constant. The only missing variable is the wavelength. So that is really all for this question. I'm going to just leave it here for a little bit, so that way you can copy this down and just write a note, you know, this is how you use it to calculate the energy of photons, just like we did in the previous question. Okay. Interesting. So I'm going to put this as an incomplete question, so that way people don't get confused when they see this, and I'm just going to mark it as wrong. But just remember, okay, they do mention actually using Planck's constant and using the speed of light, and that's really all you need. And then different wavelengths, so like if they say it was like purple, like I think it's like violet 400 nanometer range, you can use that to find what the type of energy is produced and things like that. They can even give you, because they mentioned it's electromagnetic radiation, it could be really any wavelength, but you can even find out cool things like what type of color it is based on the wavelength, and then what type of color, I mean what energy that color produces, but just small things like that. Okay, so with that, let's move on to the next question.